Chapter 4, Two-Dimensional Motion. Now, for Chapter 4, we are going to combine our knowledge of Chapter 2, one-dimensional motion, our constant acceleration equations, and the work we did in Chapter 2 with one-dimensional motion, along with our Chapter 3 vectors knowledge and the ability now to add and subtract vectors to study what we are now calling two-dimensional motion, where we are going to be looking at, as it says here, trajectories, projectile motion, and by the way, Sylvester over here juggling these balls back and forth. Each one of the balls is in projectile motion, so we'll understand the mathematics and the physics of all the balls going back and forth. We will study circular motion, and finally relative motion and some of the relativity that you may have heard of in physics will be introduced to you. First, trajectories in two-dimensional motion and some language and definitions. A trajectory is the actual path that the object follows. So please make sure you get that into your notes. So this green dashed path is the trajectory, that is the actual path. Now, notice on this graph we no longer have position versus time. We actually have position versus position. So we have the y position, we have the x position, position versus position, and time is definitely in this representation, but it's there implicitly. So at time t1, as it says here, the object has a position vector r1, and at time t2, the object has a position vector r2. Now, in terms of our language and definitions, our position vectors are always, by definition, drawn from the origin, so from the 0, 0. So notice the trajectory actually crosses the axis up here, but the position vectors are always drawn from 0, 0. Now, the displacement vector, delta r, r final minus r initial, follows the same mathematical structure of our displacement x final minus x initial, but now we're in two dimensions, is the vector going from the initial point to initial point P1 to the final point P2. So our delta r vector is given by the vector arrow from P1 to P2, and notice the delta r value is always written as if it is drawn from the origin. So that's why the delta x vector, for example, might have a vector given by 4x minus 1y, and we would draw it as if we draw it from the origin. So this vector, its length and its direction, will be the same as the vector delta r up here. Really important. So if I have exploded it in the notes, please make sure you don't miss that bit of notes. So the average velocity vector, right, delta x over delta t in two dimensions is delta r over delta t, and the delta r vector and the v vector will always point in the same direction. And of course, always in physics means always, no exceptions. The v vector and the delta r vector always point in the same direction. Well, let's go and talk about instantaneous displacements and instantaneous velocities. Well, we're going to consider the instantaneous motion as a special case of the average motion, and the special case is the case talked about down here. So please make sure you get this into your notes. We're going to let R2 happen instantaneously after R1 so that delta t goes to 0, and that's why I have the arrow shown here. R2 is going to sit right on top of R1, and that's why you don't see R2 over here on the right. It's sitting right on top of R1. When that happens, the delta r vector points tangent. If the delta r vector points tangent, the v vector points tangent, and this notation in here is a calculus notation we're going to talk about a little bit later in the course, some of the calculus versions of the physics we're studying. So where v is delta r over delta t, the calculus version, as it says down here, so again, please get this into your notes, the calculus version is of delta r over delta t is dr dt. And of course, if it's exploded, you highlight it or emphasize it in your notes. The v now becomes the instantaneous velocity, the velocity right at time t1, and that will always, and of course always means always, always tangent to the trajectory or the actual path. So there we have our introductory page of notes for Chapter 4. Let me clear up all my little markings. So erase. And you can pause the video if you want. Make sure you get all of your annotations in there. And we are off and running on Chapter 4.